Bangladesh is a country surrounded with water. It's the delta of some of the greatest rivers in South Asia, the Ganges, the Brahmaputra and the Meghna. It is also one of the poorest and most populated places on earth. In the wet season, it is often flooded, and in the dry months, there are water shortages due to upstream damming and increasing impacts of climate change. However, if these conditions were not enough of a challenge, around half of Bangladesh's rural population are now at risk from arsenic-contaminated drinking water, what the World Health Organization has described as the largest mass poisoning of a population in history. In the 1970s and 80s, in an effort to address the shortages of clean drinking water, international aid agencies financed the sinking of around 5 million shallow tube wells across the country. Unfortunately, no one at the time realized that many of these shallow aquifers were contaminated with arsenic. This red-marked well indicates that it is arsenic contaminated and has been abandoned. Arsenic contamination of Bangladesh's underground aquifers came with the sediments that eroded from the Himalayan mountains and accumulated in this delta many million years ago.
There has been a number of surveys since arsenic was first detected in Bangladesh back in 1993. We have done a lot of work since then. Now we have a clear idea about the controls, particularly the geological controls on occurrence of arsenic, both in terms of spatial distribution and in terms of vertical distribution. In terms of spatial distribution, Bangladesh is a vast floodplain, but there are some older plains, the Pleistocene uplands. We haven't found any arsenic in the Pleistocene uplands. All arsenic, what we have found, are found in the recent Holocene plains, mainly in the floodplains and deltaic plains of the major river systems, the Ganges, Brahmaputra and Meghna. In terms of vertical distribution, what we have seen, arsenic is found only in the upper or shallow aquifer, which is composed of Holocene alluvium, which are grey in color and contains a large amount of organic matter. When you go deeper into the Pleistocene sediments, which are reddish brown in color and contains lower amount of organic matter, those are basically arsenic safe.
The government has gone around most of the places in Bangladesh to test the wells and to paint the contaminated wells red and the uncontaminated wells green.
More than 20% of the wells of about more than 10 million wells, those are being used in Bangladesh as drinking water sources. At least 20% of them have arsenic above the Bangladesh standard of 50 microgram per liter. If you consider the WHO standard of 10 microgram per liter, this may go up to 50% of the existing wells. So we are talking about a large proportion of wells. And there are various estimates about the people exposed to arsenic. There are estimates. The most conservative one shows that about 21 million people are exposed to arsenic, and the highest estimates go up to 60 million people are exposed. So we are talking about a large proportion of the population exposed to high arsenic in their drinking water. When you go to the problem areas, there are two ways of immediate solution. First of all, we have to test the wells properly, and if we find safe well and unsafe wells, and if we can mark them, then people can switch to safe wells from unsafe wells. This is one way of providing mitigation. In the areas where we cannot find safe wells, we have to look for alternative solutions. This alternative solution could be either deeper groundwater or treated surface water or even rainwater.
The shallow aquifers at Kumabog village, south of the capital Dhaka, are contaminated with arsenic. A team of researchers from the Arsenic Mitigation and Research Foundation have been working here for some years. They installed this deep tube well in the village as a means of providing arsenic-free water. Dr. Masood runs a clinic in the village that treats arsenic poisoning.
This is a very big village, around about 12,000 people are there. But the bad luck is that 90% of the tubers, the shallow tubers, are having arsenic contamination. And you see the nearest place from where they can bring water, that might be more than 2 kilometers or 3 kilometers. But in our country, culturally, the main user of water is the woman. Look at the side of the tubel. All the women are coming with their pots to take the drink water. So it's very difficult for them to go 2 and 3 kilometers away and bring a better water. So we decided to have a tubel here, and that will feed at least 400 households. And look at the girls, around the clock there are more than 300 women coming and taking their water from here. Our objective is not that just giving them the tubers. Our objective is to empower them. So side by side with the awareness about arsenic contamination, we are installing a few deep wells so that instantly they can get some water for safe drinking. And they have got their own committee. The people, they form a committee, a people of 7 or 10 people. Women and men are there. Then it's the beginning of the organization. You know, our objective is that the people of this village, they form their own organization, that's the people's organization, and they find out the alternative to the contaminated water.
There are two objectives. The first objective is to give them clean drinking water directly because they need it now. All the other wells here are polluted. And the second objective is that you use the installation of a well as a trigger, a way to mobilize the people, to get them together to talk about their problems. And on the long term, it's very well possible that these wells will not be safe anymore because the arsenic might go to the deeper water levels where this well gets its water from. And in the future then you'll need to look at other technologies as well that might solve the problem at that time. And we hope by that time, if we start now with mobilizing the committee and getting these groups organized, that they will be able to shift to a new technology when those become available, and if these are not safe on the long term. So it's those two objectives: provide clean drinking water on the short term and use it as a trigger to organize the committee, to organize the community to look for longer term solutions if necessary.